Hi everybody, and welcome to our final asynchronous video for Making Modern Science. Now this is about science and medicine. We're really focusing in on medicine and how it becomes a science. And that is the main question of the chapter. How does medicine come to be a science or seen as a science by the scientific community and by the general public as well? So the general claim of the chapter is that the relationship between science and medicine that we as a society are accustomed to is of relatively recent origin, as in within the past about 150 years. Before that point, medicine was seen more as a craft or operated through an apprenticeship model. An apprenticeship model would be like you train your students by having them practice medicine as opposed to this like scientific approach to medicine. So the upshot is that it's a major cultural shift to forge this link between science and medicine, or so our authors are going to claim. So this story unfolds in lots of different episodes, but here's where we're going to focus our attention. So we're going to start with what the state of medicine was in the early modern period and review what folks thought at the time. We're going to move to the birth of the clinic and the localization of medical practice in hospitals. And then once medical practice was localized in hospitals, there was a rise of laboratory science as well. And this laboratory science often occurred in laboratories inside of hospitals. And so medicine as an experimental science is born. And then finally, the rise of new medical technologies that enabled physical medicine to be practiced in novel ways. And so we'll see what those look like. And we still use many of these new, quote unquote, new medical technologies today. Okay, so let's start with the state of medicine in the early modern period. Okay, so the state of medicine in the early modern period, we're looking around 1850. And some of the practices are kind of bonkers. Like they thought that you had these different humors and that these humors had to all be in equilibrium to make a happy, healthy person. And so as long as they were in equilibrium, you were somewhere in the center and you were happy and healthy. But otherwise, you've exhibited some kinds of dispositions. And so here are some of the dispositions that you might exhibit. So you can be phlegmatic, choleric, sanguine, or melancholic. So what are these? Well, phlegmatic is a relaxed or easygoing person. Choleric is ambitious or extroverted. Sanguine is a social or a charismatic person, and then melancholic is like detail-oriented or reserved. And so the idea is you can have these fluids out of equilibrium in your body, and depending on which one you have more or less of, you exhibit one of these personality traits. If we map it onto the different fluids, here's what it would look like. So the blood and air corresponded to sanguine. The fire and yellow bile corresponded to choleric. Melancholic was black bile and earth, and then phlegmatic is phlegm and water. Okay, so I wanted to give you some different people that this might correspond to that you might be more familiar with. So I don't actually watch The Office, but I asked my brother for recommendations. So here's what he came up with. Choleric might be Michael, melancholic would be Angela, phlegmatic might be Pam, and sanguine might be Jim. So don't hold me to this because I don't actually watch it, so I'm not sure if these are right. But these are the kinds of different personality traits that people might exhibit. So this was called humorism or humoral theory. And again, so these are different fluids that you have in your body that can be in different proportions. And you might exhibit these different personalities depending on the proportions. Now, there's another debate going on at the time, and that is focusing on whether we should understand the body to be a machine, as in this is what mechanists thought. And then there was another camp of theorists called animists or vitalists, Vitalists we've seen before. Animists were kind of synonymous with vitalists. And their idea is that the body is more than a collection of these mechanical parts. Some of the mechanists were really devoted to mechanism. Like they thought there were like pulleys and levers, etc. Like really mechanical components in the body. As our authors note though, in the end, it didn't really matter to medical practice which side of the debate you fell on. This is partly also because you have this apprenticeship model in action, and so the grander theories of how bodies work don't matter as much when it's just seen as this craft that people engage in. Okay, so I also wanted to give you a sense of who different practitioners were at the time, like who the doctors and physicians were. So there are three camps of people. We've got physicians, and physicians at the time deal with internal ailments, like I'm feeling sick, I have a cold, that kind of thing. And this is the only category of people that required a degree. I would say that they're akin to a general practitioner today. You also have surgeons. These deal with external ailments like I need a surgery. Again, no degree because they're on the apprenticeship model. And then I guess they're just like surgeons today. And then you have apothecaries. And apothecaries at the time prepared medicine, like they were doing the mixing of medicines. They also don't require a degree because they're in an apprenticeship model. They're sort of like a pharmacist today. They're not technically supposed to prescribe medicines, but I believe that at the time some still would. Okay, so now this is in like up to the 1850s, and times start to change around then. Michel Foucault documents these changes in his book The Birth of the Clinic. So the first image there is the original cover, and since then here's the updated cover, which I enjoy and wanted to show you all. Okay, so what does Foucault write about what changes are going on? So what he says is that modern medicine is only made possible by hospitals. And this is because hospitals localize medical practice. So it used to be that your physicians would make house calls. But with the advent of hospitals, they sort of can bring everybody with the ailment to a location that's central for the doctors. But this goes deeper. So hospitals aren't just physically localizing areas, like they do physically localize, but it goes further than that. With the birth of hospitals comes the birth of what Foucault calls the medical gaze. So what is this medical gaze? It's the separation a doctor makes between a patient's body and their identity, as in the dehumanization of the body that the doctor does to allow them to see the patient's body as an object of study. So if you imagine that you're a physician at the time and you're making house calls, you really understand like the person and their ailment as a whole. And this is partly because you have to go and make the house call to the person and spend the time with them. With the advent of the hospital, however, you see a bunch of patients who all exhibit very similar symptoms, perhaps, and you no longer have to like go into their house or go visit them and see them as a person. You instead see their body as this thing you need to fix in the hospital. At least that's what Foucault is arguing. Okay, so let me give you a quote from him, and apologies, it'll be really long. So here it is. What he says is, what now constituted the unity of the medical gaze was not the circle of knowledge in which it was achieved, as in perhaps the hospital in which it was achieved, but that open, infinite, moving totality ceaselessly displaced and enriched by time, whose course it began, but never would he be able to stop. By this time, a clinical recording of the infinite variable series of events. But its support was not the perception of the patient in his singularity, but a collective consciousness. So here the idea is the support for the medical gaze is not the perception of individual patients with full personalities or seen as full individuals, and having full identities, but rather a collective consciousness of seeing a bunch of different patients and sort of just looking at their ailments and not looking at them as full individuals. Okay, so that's the idea. We move from making house calls to hospitals, and with that comes this change in the way that medical practice is done. I'll just give you one more point of evidence towards this. So this is from a 1973 paper, which is also writing about the time. And in this paper, Jewson argues that there were like three main patrons at the time. So there's the patient, there's the state or the hospital, and then there's the state or the academy. And this is when we get the emergence of laboratory medicine, that the state academy really takes shape. For now, let's focus on the patient and on the state/hospital. If a patient is being visited at their bedside, this is seen as what a practitioner does, and perception of the sick person is as a full person. This is if you're making a house call. A practitioner is making a house call. When we shift to the hospital and we're doing medicine there, the perception of the sick man is as a case study, as a thing that has an ailment that needs to be fixed. And the doctor is more of a clinician. Okay, and then finally, we haven't discussed laboratory medicine yet, but here we have the perception of the sick person. If there is a person involved at all, it's just a complex of cells, and then the practitioner or the investigator is a scientist, because they're doing laboratory testing. What's the upshot of all this? The upshot is that it's not simply that clinics physically centralized medicine, they also brought about a new way about thinking about the field. With the birth of the hospital came also the desire to start looking more deeply into human corpses, really. And so your book addresses that the Anatomy Act was passed in order to prevent immoral ways of acquiring corpses. So I'll just mention quickly, prior to 1832, body snatching was actually a pretty widespread thing. So corpses would be dug up and then taken to doctors or medical practitioners for dissection, or just for the use of the body in like an anatomy lecture. And then that's why in 1832 the Anatomy Act gets passed. So today this is actually controlled by what's called the Human Tissue Authority, and they have control over like what proper disposal and what proper usage of corpses is. Okay, so that was the episode of the rise of hospitals. We're now going to move to the rise of laboratory medicine. The major figure in starting laboratory medicine was Louis Pasteur. He was interested in this debate going on at the time of whether organisms can be spontaneously created from inanimate matter. So this would be like they would have milk and it would go bad, and then their stuff would start growing in it, and they were worried that like out of this inanimate matter came living stuff. And so the question was, where did it come from? And I give the example of milk because, of course, pasteurization is named after Louis Pasteur, and it's used often to pasteurize or get rid of the organisms that would otherwise grow in milk. Okay, so he did a bunch of experiments, one of which was the following. So he used what are called the swan neck flasks, and he boils the material inside of them, and then he waits. And as long as the swan neck is totally intact, anything coming in, any like bacteria in the air that comes in through the swan neck kind of gets trapped on the inner surfaces of the swan neck. And so it doesn't actually go into the liquid in the funnel. And so if you just wait with the neck intact, there's no growth of anything. However, if you break the neck and make it so that like the air can go inside, then you end up with this microbial growth inside of your flask. And so the question, can organisms be spontaneously created from inanimate matter, seems to be answered in the negative. No, it's actually the particles and bacteria in the air that lead to microbial growth. Big rival at the time to Pasteur was a man named Robert Koch. He and Pasteur were both actually advocating for what was called the germ theory. The germ theory is simply this theory that microorganisms or germs can lead to can lead to various diseases that people were experiencing at the time. So germ theory began with Louis Pasteur and then was extended by Koch. And Koch, designs this experimental process for linking these microorganisms thought to cause the disease to the disease itself. Now, rivals of germ theory at the time were saying, like, we can't see these microorganisms, and so how could they possibly be causing the disease? If Koch was able to establish these postulates and show that if you followed them, you could actually create the disease, germ theory would sort of trump the rivals. What are these postulates? So the first is that the microorganism you think causes the disease must be found in every instance of an animal, say, exhibiting the disease. The idea here is that if you have multiple animals all exhibiting some disease, you have to be able to find this microorganism in all of them. Second, the microorganism should be isolated, as in taken out from the diseased body, and then grown in isolation. You can do the growing in isolation in a petri dish, some kind of laboratory isolated setting. Third, the disease can be reproduced experimentally in a healthy animal by injecting it with this isolated culture that you developed in step 2. Finally, you should be able to take out the microorganism again from the diseased animal from step 3, and then grow it in isolation as you did in step 2. And these are his postulates for making this link between microorganisms and diseases. A few quick notes. So lab medicine at the time and now requires vivisection. This is operating or experimenting on animals. All of the previous steps that I described that constitute Koch's principles require that you do it on animals. And so with the rise of laboratory medicine began discussions of animal cruelty. Interestingly, the anti-vivisection folks had two main arguments. So the first is what you might expect, which is that it's just morally wrong to cause pain to animals. And second, that the response of animals in extreme pain to stimuli doesn't give you any knowledge about their response under normal conditions. And so the idea here is like a questioning of how generalizable the study results may be if you take animals and put them in these kinds of laboratory settings in which they're exhibiting extreme pain. So similar to how we saw legislation being passed to combat body snatching, we actually see similar legislation being passed to combat animal cruelty. So back in 1849, there were very rudimentary animal cruelty laws, including in England at least, that you would pay £5 for the ill treatment of animals, especially cattle at the time. And then if there was unlawful killing, it may result in a prison sentence. But in 1876, we saw a much stronger cruelty to animals legislation document being passed. And then today, there's a lot more legislation around scientific procedures that you can and can't do on animals. Okay, so now we've covered both the rise of hospitals and clinics as well as laboratory medicine. Our next episode is the antibiotic revolution. So here I have a picture of Alexander Fleming, the person who sort of stumbled across penicillin. So as the story goes, Fleming was researching Staphylococcus and he left some in a petri dish, a culture in a petri dish, and he went on holiday. And then when he comes back, he sees that there's this mold growing inside of the petri dish, but that there's no more Staphylococcus. So this mold, which becomes penicillin, had gotten rid of or killed off the Staphylococcus cultures. Okay, so Beller and Morris want to sort of trouble this story just a little bit. So the story often goes in this kind of, oh, he stumbled across penicillin, isn't that amazing way. Beller and Morris want to highlight, well, it was only because of some background changes at the time that he was able to do this. And the changes are just the ones that we've already discussed. So the localization of medical practice, the rise of laboratory medicine, both of these were sort of background requirements for Fleming to be operating in the kind of scientific laboratory that he was. Now, with the rise of penicillin and other antibiotics, came the need to produce them in mass quantities, but their production was actually quite hard and cost quite a lot. And so governmental agencies started partnering with pharmaceutical companies, and pharmaceutical companies began growing a lot. So we see the rise of pharmaceutical companies like Merck, Laduril, which has been since acquired by Pfizer. So it's really this kind of collection of forces that give rise to the pharmaceutical industry. It's the need for medicines, and also the at the time, difficulty in making them in big quantities. The final episode in this series is the rise of ways of doing physical medicine that came with technological advances. So the first in this sequence was the invention of the stethoscope by René Laennec in 1816. So this allowed for better diagnostics and was pretty widely celebrated by the community. The next was the invention of the Odin coil in 1893. So this was pretty popular in use with electrotherapy at the time. So electrotherapy in this form, in the Odin coil form, isn't used today anymore, obviously, but some forms of electrotherapy are still used, like electrotherapy to relax muscle spasms, or even to promote blood circulation or muscle stimulation, sometimes used by physical therapists. At least that's where I've seen it. Maybe you've seen it in other contexts as well. Okay, so the next episode was the invention of the X-ray used on humans. So here's an image of the first X-ray taken of a human hand. This is of Anna Bertha Ludwig, who is the wife of the inventor of the X-ray, Carl Röntgen, circa 1895, and you can see her ring is still on her finger. And finally, the use of radium therapy. So after Marie Curie's discovery of radium and of radiation, it was discovered that some kinds of radiation could be used for therapeutic medical purposes. We don't still use radium therapy, but some kinds of radiotherapy are still used for killing or treating cancer. Here are the more recent advances in physical medicine or technological devices used for physical medicine. So there's the positron emission tomography, or PET scan, invented in 1953. Similar computer tomography, or CT scans, in 1972. And then another one, magnetic resonance imaging, or MRIs, invented in 1977. Now, just like we saw with the antibiotic revolution, major advances like this require industry support, or did require industry support at the time. And so we saw a ton of different technological companies get into medical technologies. Here are just a few names, some of them mentioned by your book, some of them not, of these technology companies that since have started making medical technologies. Okay, so let's wrap up. As we mentioned at the start, this relationship between science and medicine that we're accustomed to is of relatively recent origin. Before that, medicine was a craft or operated through an apprenticeship model in which people trained one another in the practice of medicine. So it was a major cultural shift to forge this link between science and medicine, and the ways in which medicine became a science was largely in this step-by-step process. So we saw first the localization of medicine into hospitals, and that enabled laboratory science to take hold in those localized areas. And then again, we saw major advances in antibiotics and the use of physical medicine technologies bring about even more or cement even more this idea that medicine is a science. One thing that your book does not mention that we'll turn to in this week's primary readings is the use of randomized control trials and how that really helps medical practice become even more of a rigorous science. And so we'll see more about that in our readings this week. But that's a step beyond some of the episodes that we've talked about today, the use of randomized control trials, but we'll see that their use really makes people take medicine as a science much more seriously.